Welcome to a session about breadth first search algorithm. So search algorithms classified into two types, uninformed search and informed search. Uninformed search, another name is blind search. Informed search, another name is heuristic search. So in this uninformed search, it does not use any domain knowledge, but it uses the domain knowledge. Here no heuristic functions are used in this technique. Uses the heuristic function h of n, explores many nodes, it explores promising nodes first. And example for the search, this uninformed search, breadth first search, depth first search, uniform cost search. Example for informed search, best first search, A star algorithm. These are all the some example for informed search and uninformed search. So what is uninformed search or blind search? So blind search means traversing the search space until the goal node is found. Might be doing in a exhaustive way. So then what is the heuristic search means? Search process takes place by traversing search space with applied rules. It contains some rules and based upon the rule, the traversing going to happen. Now let us see about the first method available in the uninformed search, breadth first search. So it is the most common search strategy for traversing a tree or graph. So this breadth first search algorithm suitable for both tree as well as graph. This algorithm searches breadth-wise. So that is why this is called as breadth first search algorithm. So in a tree or graph, so it is called breadth first search method. It starts searching from the root node of the tree and expand all successor node at the current level before moving to the nodes of next level. Another name of this breadth first search algorithm is called as level by level searching. So consider the tree structure, the starting node, the root node level called as level 0 and then followed by the remaining nodes called as next level, level 1, level 2, level 3. It is going like that. So it is the example of general graph search algorithm BFS implemented using first in first out queue data structure. So it is very important. Queue data structure can be used to solve this breadth first search method. So what is the algorithm of this breadth first search method? First step, initialize a queue and a visited set to keep track of visited nodes. Start by enqueuing the root node and marking it as visited. First node will be enqueued, node will be root node. So then after enqueue and dequeue that root node and mark it as visited node. While the queue is not empty, dequeue a node n from the front. Process node n, either we can print the value, otherwise if it is we are checking the goal node means we can stop the procedure. So we have to process node n. Enqueue all unvisited neighbors or children in a tree of node n and mark them as visited. So repeat until all the nodes are explored or the goal node is found. So this is the algorithm for the BFS breadth first search method. So consider this example. Consider this tree structure. It is already we know that it is the uninformed search or blind search. There is no domain knowledge. What type of data structure used in the breadth first search method? Queue data structure. First in, first out. So consider this tree structure. So how many nodes are available here? A, B, C, D, E, F, G, H, I, J, K, L, M. So now how many nodes we will find out? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So then we can make one queue structure. This queue structure, the number of columns will be equivalent to number of nodes. So totally it is having this tree structure having 13 nodes. So 13 boxes available here, that is in the queue structure. So now everything is ready. So we can do the process based upon the algorithm used in the BFS technique. First initial stage, we have to take the root node. Okay. So in this example, I will consider the M node as the goal node. Then what is the path? What is the traversal path for this while applying the breadth first search method? What is the path from the A to M using by applying breadth first search method? So now what is the first step? Take the root node and we are enqueue that root node in the queue structure. So then after enqueuing, we have to dequeue that A. Then we can keep that A in the visited list and then explore the A value. A node A value. So children of A, B and C. So next this B and C we can keep it in the queue structure. So A removed from the queue and then it will be added to the visited list. So then explore A and A explored in the tree structure. So children of A, B and C that will be filled in the queue structure. So B and C. So what is the next step? Next explore. This is the queue structure and we can take the B value from the queue structure and keep it in the visited list and explore the B. See the tree structure. So exploring the B, children of B, we have 3 nodes D, E, F. So this will be entered in the queue structure. Okay. So then what is the next step? B removed from the dequeued from the queue structure, that will be filled with visited list and then explore B and the corresponding children nodes added in the queue D, E, F. So then we can take the C. C from the enqueue the dequeue the C from the queue and it will be entered into the visited list and explore C. So exploring C, what are all the nodes are there here? G, H, I. These 3 nodes will be entered into the queue. So that is the next step. Consider here, remove the dequeue the C and that will be entered into the visited list and the C can be explored. After exploring, G, H, I will be entered into the queue structure. So then what is the next step? This D can be removed from the queue and will be entered into the visited list and then D is explored. So here consider D, there is no node. Okay, this is the leaf node. After that no nodes are available after D. So then just we can dequeue that D from the queue structure and it will be filled in the visited list. So then we can take the E. So next step, D will be removed and keep it in the visited list. Next step, E. Okay, so E will be dequeued from the queue structure and it will be entered into the visited list and exploring E. So see here, see the structure, exploring E. So children of E, J and K will be entered into the queue structure, J and K. And removing the F and it will be dequeued from the queue structure and it will be entered into the visited list, exploring F. Okay, see the F. Okay, after the C there is no nodes. This is the leaf node. So check whether it is the goal node or not. Each and every step we can check whether it is the goal node or not. So if the goal node, we reach the goal node, we stop the process. Okay. This process continues until we reach the goal node. The same procedure will be followed until we reach the goal node. So now the F will be, keep it in the visited list. The next node will be G. So exploring G, remove the G from the queue structure and keep it in the visited list, and explore G, the next node, that is children of G, child of G will be L, that will be added to the queue. Okay. So then next one, G is removed and keep it in the visited list. L is included and H will be removed from the queue structure and added to the visited list, because there is no exploration, because after J there is no node. This is the leaf node, and similarly K is the leaf node, and L. Okay, while coming to the L, removing the L from the queue structure, and it will be, keep it in the visited list. So then exploring L, after the L, the child of L is M. M we can keep it in the queue structure, and then removing the F from the queue structure, DQ the M, and we can keep it in the visited list. Okay. So now we can check whether it is the goal node. Yes, this is the goal node. So M is the goal node. So in the previous itself, we are assuming that A is the starting node or root node, M is the goal node, and what is the path taken to reach from A to M? A, B, C, D, E, F, G, H, I, J, K, L, M. So now you can see the diagram. So here this is the level 0. Always the root node position level called as level 0. The next level called as level 1. B and C available in level 1. D, E, F, G, H, I available in level 2. And level 3 J, K, L, and then level 4 M is available. Okay. So these are all the levels available in this structure. Totally 4 levels available. So now what is the meaning of the breadth first search? Breadth first search, apply the level by level searching. So starting from A to B, B to C, C to D, E, F, G, H, I, J, K, L and M. So this is the way, while applying the breadth first search method, we can find the solution. So this is the tree structure. Based upon the tree structure, this is the procedure to find the traversal path for the breadth first search method. So this can be applicable for the graph structure also. So what is the meaning of graph traversal? It means visiting nodes of a graph one after another in a systematic manner. So systematic method of exploring every vertex in graph data structure. So this is the meaning of graph traversal. So while considering this graph structure, what is the use of breadth first search algorithm? So here many nodes are available. Here starting node 1, 5, 6, 5, 6, 7, 8, 9, 10, 8, 9, 10, 2, 4 and 3. Okay, so this is the graph structure. Okay, tree structure, we know that level by level searching will going to happen. In the graph traversal systematic way we can check it. So here also we can start from the start node 1. So start node, from the start node, what is the traversal for this algorithm? We can see step by step. So 1 will be included in the queue, and then now the closed list is empty, and then next we can explore 1. Okay, so 1 will be moved to the closed list. Exploring 1, the 1 connected with 5, 6, 7. Okay, so 5, 6, 7 inserted in the queue. So next step, First value is first in first out procedure will be followed. The 5 will be taken out, DQ from this Q structure. 5 will be keep it in the closed list and then explore 5. So 5 connected with 4 and 9. So we can keep the 4 and 9 in the Q structure and we can remove the next value in the Q structure. First front end, what is the value? We can see 6 will be removed from the Q structure. That will be added to the closed list and then explore 6. So 6, if you are seeing the 6, 6 connected with 10. So 10 included in the Q structure. So like this we are following the procedure. So next we can have that 4, 9, 10, 9, 3. So while exploring 7, we can have this Q structure. While exploring 4, we can have the Q structure 9, 10, 3, 2. While exploring 9, we have the Q structure like this 10, 9, 3, 2, 2. And while exploring 10, 9, 3, 2, 2, 8. While exploring this 9, we can have that 2, 2, 8, 8. And then while exploring that 2, we can have 2, 8, 8. While exploring 8, we can have that value of 8 only available in the Q structure. So finally, what is the BFS traversal for the given graph? 1, 5, 6, 7, 4, 9, 10, 3, 2, 8. Okay. So this is the way we can apply the breadth first search method for the graph structure also. We can implement it. And this is another example. While seeing the diagram itself, this is the tree structure. So tree structure and graph, everything we can apply the level by level search. So what is the answer? From the diagram itself we can tell P, Q, R, S, T, U, V. This is level 0, level 1 and level 2. And consider another example. So here these are all the levels. So how to find out the path for the BFS algorithm? S, A, B, C, D, G, H, E, F, I, K. Okay. So this is the way we can easily find. But in the exam point of view, we can write all the procedure and find the solution. So breadth first search algorithm. So what are all the advantages and disadvantages? It will provide a solution if any solution exists. So definitely it will provide the solution in the search space if any solution exists. If there are more than one solution for a given problem, then BFS will provide the minimal solution which requires a least number of steps. So what are all the disadvantages of breadth first search method? It requires lots of memory. So level by level searching going to happen. So in the last level our node is there means our goal node is there means we can explore all the nodes. Okay, it requires more memory. And then BFS needs lots of time if the solution is so far away from the root node. So time complexity is also more and space complexity also more. So this is the disadvantages of breadth first search method. Thank you.